Module 4, Expressions, Linear Equations, and Linear Inequalities. This is section 4.4. We're going to look at the addition property of equality. This is going to be one of several properties that we're going to be able to use to solve equations. An equation, remember, is a mathematical sentence that has an equal sign. Expression is when there is no equal sign. So you can think of an equation as two equal expressions. Equations have equal signs. There's an expression on each side. If you only have an expression, notice that there's no equal sign. It's just a bunch of terms. Some may be like terms, some may not. But there's no equal sign and no inequality symbol. If we have one variable, one letter that is not a number, we're going to be able to solve that equation to find out what x value I need to plug in to make the mathematical sentence true. An equation that has a variable raised to the first power with just one variable is called a linear equation. The property we're going to look at today is the addition property. And it's a little sneaky because it's really addition and subtraction, because subtraction is just addition of a negative number. And so even though we're going to call it the addition property, we're going to think about the fact that if I add the same number to both sides, the equality will remain. So if A is equal to B and I add the same number to both sides, the sum on both sides will still remain equal. And it's the same thing as if I subtract the same number from both sides. So for example, 4 minus 1 is equal to 4 minus 1. Well, then both sides have to be 3 is equal to 3. A better example might be 2 plus 3. We know that that's equal to 4 plus 1, right? Both sides are 5. I can add 5 to both sides, and I'll get 2 plus 3 plus 5 is equal to 4 plus 1 plus 5, and both sides are still 10. So the equality remains the same. If I had the 2 plus 3 is equal to 4 plus 1, and I subtract 5 from both sides, this side would be a 0, and this side would be a 0, and so the equality would remain the same. We're going to solve several examples in this PowerPoint, and we're going to have to remember to deal with any parentheses, whether it is that I have to group terms first or distribute. And after you distribute, you very often have like terms that you're going to have to combine. I'm going to start to make a list of steps off to the side. The first is going to be distribute. Not that we have that yet. The second will be to combine like terms. Then we're going to kind of have a jump, because in further videos, as you get more complex equations, we're going to have a few extra steps in here. But for this video, our third step is going to be to add or subtract. And we're going to fill in a few more steps before that and a few steps after that in further videos. Let's look at our first example. X minus 4 is equal to 7. Think about it as doing the opposite to both sides, or the inverse operation. I'm subtracting 4 from both sides. If I fill in that hole by adding 4 to both sides, I would have x minus 4 plus 4. Well, that would be an x plus a 0, so I only have an x. On the other side, I would have 7 plus 4, and that's 11, and then I'm all done. So if it looks like subtraction, you add it to the other side, and if it's addition, we're going to subtract it from the other side. Now you can check every single equation by making sure it really works. If x is really 11, when I subtract 4, do I get 7? Yes, because 7 is equal to 7. That's a true statement. We don't check every single equation that we solve, but in the beginning it's a good habit. That way you can make sure you're not accidentally stumbling upon the correct answer. Y minus 1.2 is equal to a negative 3.2 minus a 6.6. So on our list of things to do, first we have distribute. And then we have combined like terms. So I'm going to shorthand to CLT. Well, I have like terms on this side. I have a negative 3.2 minus a 6.6. When you're subtracting integers, you take the difference between the two, and then you take the sign of the one that has the larger absolute value. You may have also at some point learned keep, change, change. That way you change all subtraction symbols to addition symbols. I'm going to just rewrite this side because we haven't done anything over there yet, and then I'm going to add these two together. A negative 3.2 plus a negative 6.6 is a negative 9.7. Now I have y minus the 1.2. The inverse of subtraction is addition, so I'm going to fill that hole in. But whatever I do to one side, I have to do to the other. This is going to add to 0. If the side that you're adding and subtracting with the variable doesn't just leave the variable when you're done, you added or subtracted by the wrong number. You want this to zero out so that you have the y all by itself. Now I have a negative 9.7 plus a positive 1.2. So I'm going to take the difference between those two numbers, which is 8.5, and take the sign of the larger absolute value. That's a negative, since 9.7 is a larger absolute value than 1.2. So y is equal to a negative 8.5. A little bit longer. I still don't have any parentheses that I need to distribute, but I do have a bunch of like terms. Let's talk about like terms. You're a like term only on that one side. So 6x and a negative 5x are like terms. They both have the same extension, right? They both have the same variables raised to the same power. 6 minus 5 is a 1. But 8 and this 8 are not like terms. They're on opposite sides. So it's like being in two different families. Somebody can have a daughter in each of the same houses. It doesn't make all the daughters sisters, right? So this 8 is just going to stay over here. But 8 minus 3, those are like terms. They're on the same side together, and 8 minus 3 is 5. Now instead of filling in the hole, I'm going to take some off. I have too many. I got plus 8. I need to take that 8 off and say minus 8 on both sides. Think about doing the inverse operation. What gets you to the identity? If it's an addition, subtraction is going to get you the identity by adding the opposite. That's now a 0. I'm left with an x. 5 minus an 8, you can think about it as a keep, change, change, if that helps. And I get a negative 3. You can check it. It's a little bit longer. If x is truly a negative 3, when I plug in a negative 3, these two sides should be the same. I'm going to say 8 minus 3 is just a 5, just because I'm out of space over here already. 6 times a negative 3 is a negative 18 plus 8. And then I have a negative 5 times a negative 3, and so that's a positive 15. Is this equal to 5? Well, this would be a negative 10 plus 15. And yes, these two sides are both equal to a 5. And so therefore, I solved correctly because my check worked out. Now finally, a distribute. So first I'm going to need to distribute. And then I can start thinking about combining like terms. 3 times 3x is a 9x. Times a negative 5 is a negative 15. You hint the parentheses, so that's done. There's nothing else left on that side, so I'll put the equal sign and then a 10x. I don't have any like terms. This is an x and then there's no x. And then this 9x and this 10x are on two different sides. So that doesn't work out. On top of that, I have a variable over here and over here. That's a problem. We're going to need to get all the variables to one side. Doesn't matter what side. I can bring the 10x over to here, or I can bring the 9x over to the other side. That's a positive, so I'm going to subtract it from both sides. And I'm left with a negative 15 equal to, well, just an x. And that worked out well because I didn't have any like terms and my variables were on one side and I don't have anything left to add or subtract. Right? I don't have x plus or minus a number, so I'm all done. (4p minus 11 minus a p) equal to 2 plus 2p minus 20. Our list is getting longer. Distribute? Well, not this time. Combine like terms? Yes. Get variables to one side? Yes. And I'm going to add in one more, and that is to get numbers to the other. To solve an equation, you want all the stuff with letters on one side and all the stuff without letters on the other. It doesn't matter which way you go, if it's left or right. You know, people tend to like their variables to the left, but it doesn't really matter. And I'm going to skip a little bit because there's going to be other things later on that we'll need to do. And we'll do our add and subtract. We may or not need that this time around. So let's talk about combining like terms since we have nothing to distribute. I got a 4p and a negative 1p. Remember, if you don't see a number, it's a 1. And 4 minus 1 is 3p. Minus 11, because there's nothing else on this side, so I'll just bring the rest down. 2 minus 20 is a negative 18. And I don't have anything else on that side to add with the p. Now, 3p and 2p are not like terms. They're not on the same side. Negative 11 and negative 18 are not like terms because they're not on the same side. So we're done. Now we want variables to one side. Let's bring the 2p over to this side. So I'll say, well, this is a plus 2p, so minus 2p. They would be like terms, so I'll just put it right next to the p. You could put it at the end, but it's going to have to get combined with the 3p. 3p plus a negative 2p is just a 1p. Minus 11 equal to negative 18. Now I got to get my numbers to the other side, but in doing that, I'm really doing the addition and subtraction problem part of this. This is a minus 11, so I have to say plus 11. That adds to 0. And now I have a negative 7. This is called a two-sided equation because it has numbers and letters on both sides. If you only have letters on one side, variables on one side, that's a one-sided equation. It's two-sided if you have variables on both sides. It's also a multi-step because, well, as you can see, we had several steps. Last one, and I think we have everything this time. We have a distribute. That's the first thing I need to do. And so I'm going to say 5 times 3, 5 times z. That set of parentheses is done. Now I need to send this negative 1 through. Negative 1 times an 8z is a negative 8z. Negative 1 times a 9 is a negative 9. I only have a negative 4z over there. So I'll just write that over. And now I got to combine like terms. Like terms are on the same side, so I have a 5z and a negative 8z. That's a negative 3z. I write the dash through the z because my z's tend to look like 2's after a little while. 15 minus 9. 15 minus 9 is a 6. And I have this equal to a negative 4z. So you can see we have another two-sided equation. So I'm going to need to get variables to one side and numbers to the other. But if I bring this 4z over this way, then I have nothing left over there, and I'll have to do this extra step of bringing over the 6. If I just go ahead and add the 3z to both sides, I get 6 is equal to a negative z, which looks like a negative 1z. Now, we really want this to just be just z. Notice all the other problems, it wasn't negative p, it was just p. It wasn't x, a negative x, it was just x, right? You want the variable to just be positive. Well, you can think about it two ways. You can think about taking the opposite. Well, if negative z is equal to 6, then positive z has to be equal to a negative 6, right? Because they're just changing signs. Or you can think about dividing both sides by a -1 or multiplying by a -1. But this time we didn't have anything to add or subtract. So we are all done. That's the hardest one in this section. There are several examples throughout the textbook that you can look at, and I also will have a practice website for you to try some other equations at.